Alright, let's see how we can use exponent rules with rational exponents, or in other words, fraction exponents. And the exponent rules are the same whether you have fraction exponents or integer exponents. And here's a summary of the rules right here that we're going to be looking at. If we have two same bases being multiplied together, raised to powers, we're going to add the powers. And if we have two same bases being divided, we are going to subtract the powers. If we have a base raised to an exponent and then that whole thing is raised to another exponent, so if we have a power to a power, we multiply the exponents. And if we have two different factors raised to a power, the exponent goes to each one separately. So an exponent distributes over multiplication, and that would also work for division. Alright, so let's go ahead and try out a few of these. X to the 1/5 times x to the 3/5. We have expressions with same bases being multiplied. That means we're going to add the exponents, like this rule right here. So we get x to the 1/5 plus 3/5, or x to the 4/5. In the next one, we've got x to the half raised to the 3/5. That means we have a power to power, and for power to power, we multiply the exponents. So that gives us x to the half times 3/5, or x to the, and here we don't have to worry about common denominators because we're multiplying fractions, so we just go right across the bottom, right across the top. So 1 times 3 is 3, 2 times 5 is 10. And there's our answer. And the last two, we have expressions with same base and they're being divided, we're going to subtract the exponents. And let's deal with the numbers first. So usually deal with numbers separately and then each like base separately. In this case we only have one like base. But for the numbers we can divide by 7 top and bottom, and that's going to leave us 6. So we get 6 and then x to the 3/4 minus 1/3. And it's always the top exponent subtract the bottom exponent. And notice that we're not putting anything in the denominator here. We're going to leave the base in the numerator of our final expression. And that gives us 6 to the, or 6x to the, and now we have subtraction of fractions, so we do have to worry about common denominators. So let's make the LCD of 12, which means I need to multiply by 3 top and bottom for the first fraction and by 4 top and bottom for the second one, which gives us 9 minus 4 all over 12. And that comes down to 6x to the 5/12. And our last problem, we have a bunch of factors or items being multiplied together, all raised to a power. That means that each of these factors gets the power. So that's 64 to the 1/3, x to the, now this already has an exponent, so it's x to the power to power multiply, so 6 times 1/3, y to the, again there's a power here already, so we multiply 9 times 1/3, and z to the -3 times 1/3. And now we can evaluate 64 to the 1/3. So it would be the cube root of 64, which is 4, x to the, and 6 times 1/3. You could think of it as 6 over 1 times 1/3 if it's a bit easier to look at that way. And we can do some canceling here. Divide by 3. So that's going to give us x squared. And we can do the same kind of canceling on the next two. So if we divide by 3, and 3 and 9, we're left with y cubed. And for z, if we divide by 3, top and bottom, we're left with -1 times 1, so z to the -1. And we're almost done, but to be completely simplified, the expression cannot have any negative exponents. So we need to take only the base that has a negative exponent, which is the z, and shift it down into the denominator. So that means we're going to have 4x squared y cubed in the numerator. Shift down the one with the negative exponent, and the exponent becomes positive. Now you don't have to write the 1 here, but I'm just going to put plus 1 so you can see what happened. It was in the numerator as an exponent of minus 1. When you shift it to the other position of the fraction, the negative becomes a positive exponent. And there would be our final answer.